Our lesson today is on domain and range. And if you recall in our function notes, we talked about input and output, which is exactly the same as domain and range. So we'll just rewrite those definitions here. The domain is the set of all x values in a relation, which is just a set of ordered pairs. And the range is then the set of all y values in a relation or set of ordered pairs. And when we talked about functions and relations, we talked about things like a set of ordered pairs or a table or a mapping. And lastly, we looked at graphs. We're going to do the same thing today, but what we'll notice is that when we look at the first two on that list, we're going to do one kind of technique. And then when we get to the graph, I'm going to show you a different technique because our writing is going to look a little bit different. One thing to take note here, this will come more into play when we get to graphs, but since we're looking for x values for the domain, we're going to run from left to right. And when we're looking for our y values for range, we're going to go from the bottom to the top or from low to high. Okay, and that'll make more sense on the next page. So just to show you a couple examples of the sets of ordered pairs or a table or something like that, really all we need to do is, first of all, we want to specify which one's which, so we'll put a D and R for each of these. And then literally the only thing we have to do is list out, first of all of the x values for the domain, all of the y values for the range, and then we need a little bit of notation with that to justify it as domain and range. So in order to do that, we use what's called, in fancy terms, these S brackets. I'll show you what the other two types, they're just square brackets and parentheses. We'll see those on the graph. But if you're not so good at making the S brackets, you can literally just make a squiggly line. It's just got to look different than the other two types of brackets that we're going to be using. So for our domain for this first example, we'll pull out all the x values. So 1, 3, 4, 5, and 6, and then use another squiggle at the other end. And then our range is just the y values, which in this case we've got 4, 6, 8, 2, and 10. And as far as ordering is concerned, I don't care what the order is. Typically, if it's already given to you, it's going to be in numerical order. But you can see in the range, I went in the order that the ordered pairs were listed instead of putting the 2 first, and that's fine. I'll do the one for the table. Remember that in a table, they're going to label your x and y. So in this case, our domain is just that left-hand column. Same notation, we'll start and end with the squiggly brackets, or the S brackets as they're fancily called. And then our y values here, the only difference on this one is we have two 25s. With domain and range, we don't want to write repeats. So even though there's two 25s, I'm only going to write it one time. So go ahead and pause the video and try the other two domain and ranges, and then come back and check your answers on the screen. And you can see that I filled out what the domain and range should be for each of those. Just remember with the mapping that whatever oval comes first is your x, and the second would be your y. So domain would be first and range would be your y. And that's it. When we're looking at a set of ordered pairs, a table, or a map, we're going to use the same idea where we're just listing out all of the x values and all the y values, domain and range respectively, and then we use squiggly brackets to indicate our list. When we jump to the graphs on the next page, this is when we're going to switch gears. So a couple of things to keep in mind. First of all, we want to look at a graph and analyze a little bit before we get started. So if I look at the graph I have currently on the screen, one thing I notice is that the coordinate plane kind of looks like it got cut off over here at the right-hand side of the x-axis. So if I think about it, I would imagine that this graph is going to keep on going to the right beyond what I can see. So I'm going to add arrows to indicate that. Then one of the tools we'll use in class is an index card to help us identify domain and range. So remember on the front of the notes, we wrote that domain runs from left to right. So if I grab an index card and kind of cover up my graph, what I want to do is scroll the index card until it hits the first point on the left-hand side that relation touches the index card. And if I kind of follow this line right here, it looks like that point would be right here at -4. So my domain starts at -4. Then I'll keep sliding my index card until I reach another stopping point, which in this case, you can see, because the index card is under the typing that I've already done, it's under the arrows, which in math, the arrows indicate it keeps going on and on and on and on to forever, which our math term for that is infinity. So in this case, our domain is from -4 to infinity. Now I'm going to pause here and give you some notes about the other couple brackets that we're going to see. So I mentioned, if you want to kind of write a list up here at the top, that the squiggly brackets are for lists. So if you have like just a couple x values or a couple y values, just like the sets of ordered pairs in the table, you're just going to put those in squiggly brackets. That's more for that type set. We don't see that too often when we're on the coordinate plane. The other two types are what are called square brackets and parentheses. Square brackets are for things like closed dots or solid lines. So if I look at this graph in particular that I have on the screen, everything here is solid or what we would call a closed dot. There's no point on that graph where there's an opening or something like that, which means when we look at parentheses, we want to use those for the opposite. So open dots, and then the other special case that we use parentheses for is either of our infinities. So if we would have a negative infinity or a positive infinity. So in this case, if we jump back to our domain is going to be a closed or square bracket around -4 because there's not an open dot there, and then it's going to use a parenthesis on the other end. Now, if I grab my index card, we'll rotate it the other way, and now we're going to scroll from bottom to top. So in this case, the first thing that I hit as I scroll up is an arrow. And this arrow is pointing downwards for the y values, so that means it's headed towards -infinity. Then we'll move the index card up until it's at the top of the graph, the furthest place that we see. And again, this time we end on an arrow, but this time it's headed upwards, so that's going to be a positive infinity. And both of these are going to get our sets of parentheses. Now, there are a couple other ways when you're on the graph to write domain and range. You can use this notation that I've just showed you, which is known as interval notation. You can also write it in inequality format. So if I rewrite what I already have written here, domain is our x, so it would actually look like this, where it's saying that the x falls between -4 and infinity, or basically that x is greater than or equal to -4. If I look at the one for my range, the y values fall between negative and positive infinity, and we use these parentheses or the non-equal to inequality symbols because we can't actually touch infinity. It always keeps going, so we can never actually reach it. The last way that you might see when you're looking at our test for this unit, or if you're looking at USA Test Prep or something like that, you might see it written in words. So, and I kind of have been speaking what it may look like. So for the domain, the way to write it for this particular one is all real numbers greater than or equal to -4. And then the range is even easier because it's literally all real numbers. There's nothing excluded here. Now, when you're doing these practice problems, you do not have to write it 3 different ways every single time. You probably will want to get comfortable with the interval notation because that's the shortest way to write it. But you want to familiarize yourself with those other 2 ways so that if a problem has the inequality notation, you know how to look at it, or if it has the words, you know how to translate that to the interval notation.